Thank you everyone. Appreciate you all taking some time out of your day to come and see David and myself and our team's hybrid home and the construction approach that we've taken here. Essentially what we've tried to achieve is using standard building practices, standard building materials, but achieve these really high performance outcomes. This journey sort of began, I guess, with an initial project that we did together in collaboration, and it was sort of aimed at looking to achieve a passive house certification, and realising that we had some budget constraints, which I'm sure a lot of people can probably relate with, and how we can then pull all those sort of specific details apart and then reapply them with those standard practices and materials. I think, if you're happy to, we can...
Yeah, before we do get into it, just a bit of housekeeping. So just out of curiosity, have we got any builders in the crowd? Put your hand up. Yep, thanks guys. Any tradies in that? Yeah, a few tradies. And anyone interested in building? Yep. And anyone just rocked up just for the sake of it? Yep. A couple of little stragglers there, that's all right, that's fine. No, I really appreciate you all coming. I know I find with social media and that, like, you talk to a phone and you don't think you're talking to anyone at the end of it, but it's obviously you hold events like today and you do realise that there is a few people listening, so thank you for that. So just a bit of housekeeping about, this is the actual construction site, so please respect that, be careful. There is a sort of gravel path around the site, and as you can see it is quite steep and rocky terrain, so please stay sort of, you know, stay safe, and if you do hurt yourself, I don't want to hear about it. Another thing is that, as I said, it's a construction site, so this is someone's home, which we're really appreciative of the owner to allow us to share this with you guys. But you know, there is a lot of finished products installed in the homes, like all the doors and that, so we've taped up all our sills, which I do anyway, standard practice, but when you step through, please step over it because you are stepping on someone's new product, so yeah, please treat that with respect. Another thing is that this is obviously a construction site. It's a moment in time for you builders and traders out there, is things that aren't finished, so go easy on us. We did have a bit of water come in last night, just down here with these jut outs with no parapet flashings on, that sort of thing, and your noggins missing that, but yeah, just understand it's a construction site. So obviously I'm David Millard, the builder of this project. My company's EcoWise Homes. Anthony Outlier. Stuart Dawson from Thermalux. Stu, do you want to come up and have a bit of a chat about your involvement and what you do?
Hey everyone, my company Thermalux, we're an installations supplier and contractor, so we supplied the building wraps for this project and also installed the glass wool bats inside.
Cool. Yeah. And very well done, might add. Yeah.
Thank you.
So Stu's got a little table set up in there, and yeah, feel free to afterwards go chat to him about different products that he can you know, use for your home and your design, that sort of thing. So I suppose a bit of background about me. I've been in the building industry since 2006. Started off with a small building company, you know, just the builder and I as an apprentice, and that was really good, learnt a lot from him, and then progressed through, worked for another company as sort of like a leading hand site manager and that, and then went out on my own and, you know, did a HR Green Smart course, which is like a 2-day course and sort of an introduction into sustainability and high performance building, and I sort of walked away with that a bit like gobsmacked, like a few simple principles of building as far as orientation. Doesn't cost any extra to build, twist a house, you know, to a certain degree to get the correct orientation, but it was overlooked by, or still is overlooked by a lot of designers and builders and that. And yeah, since then, furthered my studies, became a passive house tradesman, and I think I've probably got the most knowledge from, you know, just Anthony and I just experimenting with things and chatting, and just numerous evenings scrolling through YouTube and coming up with different ideas and that sort of thing. But yeah, thanks for coming, Anthony.
Yeah, no, I probably won't touch too much on my backstory, but yeah, we've sort of, Outlier has begun and sort of always sort of focused on trying to just do better, and that's a big part of that's been passive house and passive solar design principles. And so yeah, every design we feel should incorporate that aspect of it, and we'll touch on all of the details of that, I guess, as we walk through it now. we would like to jump into that now.
Yeah, go for it. Yeah, go for it.
Okay, so this particular site has a few constraints. So I'll talk about the design and then move into the performance aspect of it all. So we do have an unused government road that borders this home. So if you're thinking, why is this long shape and form in which it is, that's north that way. Hence why we've got our living space to the north with as much glazing as we can. And then we've also incorporated some little jut outs here, which also allow us to continue that northern glaze or northern light down into the home further down. There's no surprise why we'd also incorporate glazing at those particular places down the home when we've got views on both sides. So when you get time later to walk around and have a look, you'll sort of see, you know, it captures a lot of that. So beginning, sort of those constraints, we sort of had the form of the building and that sort of gave us that to work with. We then sort of were able to prioritise where the living spaces were going to be. We have the bedrooms and other rooms to the rear, to the south of the home. And then, we can move into the thermal specifications. So the slab is completely uncoupled. So it's continuous XPS insulation. We have perimeter slab edges right round, but we don't really have any internal here except for a single joint in the middle of the home. And that's completely wrapped and encapsulated in an insulation board that's specifically designed to take that bearing capacity of all that weight. And that's thanks to Stuart as well. So that now has completely thermally broken that from the ground. With some of the testing and research we've done with our own sensor array systems, we've seen temperatures of 8-9 degrees in the soil here. So we know that the internal temperature is going to be more than that typically. We're looking at sort of around 20 to 23 degrees most of the time internally to keep it nice and comfortable. So therefore we know that if it wasn't insulated, it's going to always try and suck that heat or leach that heat into the ground as that energy or the heat is trying to get to that colder environment. So by putting that XPS insulation on there, we've now reduced that quite significantly in that heat transfer occurring, and it's keeping that internal temperature stabilised. From there, we've got our external wrap. This here is a good example of the two different methods that we've taken in our external ventilation strategy. For the rake ceiling, with the inside here in the open plan living, we've got that wrap that continues up and it's taped and air sealed, and it has a ventilated cavity on top of the larger rafters you can see in the yellow alveoles here. And that allows continuous airflow up the exterior of this wrap and then continues up to the roof where we've got a lysite or similar venter roof system, so that airflow is continuously occurring at all times on the outside of the wrap. And that can be intensified with what they call the heat stack effect. So as heat's applied to that exterior cladding through the sun, it then causes that hot air to rise and encourages that ventilation to occur.
The whole purpose we did that on, so you can see the connection there, that anything that side, that's the ventilated cavity, and then this side we've got the ventilated roof space. So the whole purpose, when we go inside, you will see that this ceiling is a cathedral ceiling, and we were concerned with the insulation bats virtually touching the plaster ceiling inside, and then, you know, touching not the roof sheets but the wrap, that there's no ventilation in that roof, that, you know, we could have more risk of condensation, that sort of thing. And do you want to keep chatting?
Just on that note, so this wrap is a class 4 vapor permeable, so not having that ventilated roof space like they do have with the flat ceiling, you're relying on the water vapor being able to pass through the materials and through the membrane and ventilate external to the membrane. Yeah. So,
which is, that vapor drive of that energy being the heat pushing through in that direction to outside. So it's taking any moisture with it in that direction. And then we have the other application here where we've got an anti-con blanket on the roof, which is reducing the condensation risk up underneath the roof sheeting as it keeps that roof sheeting temperature a little bit warmer that prevents it from condensating. And again, we've got sensors in roofs with anti-con in them, and to date we haven't had a single occurrence of condensation occurring using the anti-con. So in this instance here, the wrap stops short. So what it's allowing is ventilation to occur up the wall still, but then into the roof space, and again out the ridge capping, which is ventilated as well. So a different approach this time round. We're looking at trying to create airflow over the top of the insulation, hence why we've also got a bit higher wrap here to stop any wind washing or reduction of the efficiency of the insulation, but then allowing that airflow to occur above that and then continue out and out the roof at the ridge capping, at the ventilated ridge capping. So that sort of covers the external wrap. Behind that is a 140mm stud with an R4 bat inside of it. and it actually hangs over the slab edge 50 millimetres, which is the exact thickness of the XPS insulation. So that allows us to have continue that wrap down past the bottom plate of the timber stud wall and over that XPS, and we can then continue our cladding over that as well. So it's nice, it's on the same plane essentially. Yeah, I don't know what was...
Yeah, so the other thing is, like, with the whole wall system is what we call a ventilated cavity as well. That you see here, we've got a counter batten that keeps this timber wall batten 20 mil away from our wrap. So that way, which, you know, in the middle of winter, we will get condensation forming on the back side of there's got corrugated iron wall cladding here. We will get condensation forming on there. But the beauty of this is that condensation will form, and it's 55 mil away from our wall wrap and 50 mil away from our wall frame. So if any condensation does form, which will, we'll then just drain down the back of the cladding and then, you know, out exterior. And I think, like, the building wrap and that, it serves two purposes. That we're making the home airtight with this to stop wind washing effect within our walls, but we're also stopping moisture in that going into the home, like that condensation I just touched on. And talking about, like, the air tightness and that, it's the building wrap goes 50 mil past the bottom of our bottom plate. And on this project, actually got two bottom plates, which I'll show you inside a bit more detail. And that wrap's been polyurethane to that bottom plate. So then it's airtight, it's overlapped 50 mil. So if any condensation does form in that cavity, it can drain straight out. And then obviously you can see all the attention to detail of all the wrap has been, all the joins have been taped. Any penetrations that we have coming
Just
through is all sealed with tape to ensure, yeah, again, no, a wind washing effect, but then, you know, we don't want any condensation or moisture getting into our frame. Obviously, you know, timber lasts a long time, but if you leave timber in water, it doesn't last too long. So it's about keeping that building dry.
Yeah, no, I think it'd just be good opportunities to touch on the importance of a building envelope. You know, number one, we've always got bulk water. Anyone who's built or is in the industry will probably appreciate that bulk water is going to be the number one killer of a home, whether that's water that's coming externally or a bathroom waterproofing fail. And number two, you know, we have got that air tightness as well, which brings in vapour, which is at number three. And then lastly, we have our insulation as that layer of importance. But I thought I'd just mention too that, you know, we do have to consider things like the bushfire requirements out here. So ember guard underneath the ventilated cavities also stops bugs and insects from coming in. Right. The windows and doors are also continually taped right around, as you can see here with the white taping. Again, that's creating a nice weather seal and air seal. But at the bottom, it's a little different. There's a graded sill pan under here, which incorporates a back dam. So typically, if water externally is coming down the exterior of the facade of the home, the windows are the weakest point, or the doors are the weakest point. And when water hits that, it's going to drain down the sides. And we want to ensure that it doesn't have any capillary action or any ability to get back into the home. So having a graded sill pan, any moisture or water that finds its way down this window or door is going to just grade out down the ventilated cavity. Yeah, everyone feel free to have a look at this. There's a few on a table out the front as well, but this is that one point of difference that gives life to a home, or I suppose, yeah, you know, that durability to a home is managing water.
Yeah, it's like, you know, people say your windows shouldn't leak water, which, yeah, they shouldn't. But we're talking 80, 100 years down the line, that if this window, you know, slowly breaks down, that we want our frame to be structurally sound. So you probably can't see it, but this building wrap here actually returns all the way back to the internal part of the frame. When you're inside, you'll actually see it, a bit of the building wrap there. So that's 100% sealed. So if water does leak up the top of the window and gets in between the window reveal and our frame, that we've got that building wrap there to protect it, and then it's all sealed with polyurethane. It's just about trying to build buildings that last longer.
Yeah.
And you know.
And again, just durability. Obviously, termite protection is also pretty important here. So we have a physical termite barrier that continues under the bottom plate as well, which you'll get a better look at inside as to what David has touched on with the two bottom plates and why we've done that. I think that probably covers everything. If anyone's got any questions about the exterior here, or if you want to hold on, you can also have a chat one-on-one afterwards as well, if you wish.
Yeah, but we may as well concrete inside and yeah, have a look.
So if it's not apparent, I will just clarify that this home is being built to be airtight. And what we mean by that is that we're trying to basically get this home to a point where it's not leaking air uncontrolled. So when we get to those sort of levels of airtightness, we need to ensure that we still have ventilation in a home. So this home will have a heat recovery ventilation system, which provides continuous continuous airflow, filtered airflow through the home, as well as extracting at all times, 24/7. It's got a really low energy consumption, so it just ticks away in the background at very low rates, and just makes sure that this home is always being provided with, fresh filtered air, and it's ensuring that all of that stale and contaminated air from, say, toilets or even bathrooms, it'll manage condensation and remove that from the home and keep the relative humidity in the home at an optimum sort of comfort level. So a big part of what we just mentioned before is this is north, straight behind us, hence why we've got a larger amount of glazing here. Given the form of the building, we had to incorporate as much as we could on this facade. It also means that when we go airtight, that we're at risk of overheating essentially. It requires very little energy to heat this home. So once we're at that sort of efficiency level, we want to basically ensure that our shading is optimum. I don't mean thereabouts rule of thumb, I mean optimum. Like, it must be considered strongly, or you will have those issues of overheating in the summer months. And all of that effort of having a comfortable home can go out the window, literally. So we've got a depth here that's been analysed of our eaves. So that eave there will shade that upper window. And we also have a timber pergola structure that will be installed at a later date out here, which will provide the shading to this lower doors, sliding doors here. They have got louvers on them, I believe.
Yep,
Yep, louvers on them
yep.
that are angled at the winter sun angle for the first 1,200 or 1.2 metres out. The lift and slide doors, do we want to touch on those?
Yeah, and Anthony's just talking about shading the north with horizontal shading, which that's ideal when you're doing north. But western shading is very different. Obviously, that sun's setting in the afternoon, so horizontal shading is only going to do it for a short period of time. So on this project, you'll see when we move forward, there's a bit of glazing on the western side. So that will have all rusty cordon steel blinds on it. That's perforated holes about 40% or something like that.
Yep.
And I think that look really good because it's got the zinc aluminum corrugated cladding going right around the home. So it's sort of the whole purpose or the whole style of this job, sort of a industrial sort of shearing shed sort of look and that sort of thing, and it'll obviously blend in the hills quite well out here. But yeah, lift and slide doors. So these are Ultimate Windows Zendale range. They do have another range on top of this, which is their premium range called the Legend series.
Yeah.
But yeah, this is their Zendale range. But yeah, UPVC, high performance. The reason this is a lift and slide door, so you can see it's in the sliding motion now. And then once it's closed, you just crank this handle. I don't know if you can actually see that, but it actually drops down off its wheels. So that way you get a continuous seal at the bottom. Once you start getting the home airtight, you find that your normal sliding doors draft a fair bit of air, like once we're talking airtight homes. Obviously, you need that clearance between your wheels and your rollers and your track and that. So I'll do it one more time, I don't know if you can see it. It just drops down and locks it on, so yeah.
Yeah, and they've been rebated into the slab as well to reduce that threshold from inside to outside, so that step over, yeah.
Do you want to chat about the wood heaters in here in Rangewood?
Yeah, so we've got a few sort of challenges to overcome when we go airtight when it comes to wood heaters or wood stoves, which we do have in this home, as well as an exhaust or range hood that ducts to outside air. So how do you stop air basically from just freely flowing uncontrolled? So the wood heaters actually have a direct air supply that comes into them from exterior air, which then stops the usage of the air within the home like a traditional wood heater or stove would do. And the same principle applies with the range hood. Like typically you would have, an exhaust that goes directly to outside air. And often in airtight homes, that is what they'll usually put a recirculation kit in. So the air actually goes through a charcoal filter. The fat or oils are collected in that, and then the air is circulated back into the home. However, in this instance, we've opted to go outside. So we've got a fresh air supply that's built into the range hood. So it brings its own fresh air supply in to a certain degree, and then allows that extraction to then occur outside. And the use of some really airtight back dampers stop that airflow from occurring unless it's in operation. Anything further to add to that one?
No, I think this project, like where you may hear us refer back to Passive House a bit, and we both love Passive House, a big fan of it, but it does come a certain price point in that. But so we're not trying to achieve a goal of air tightness here. Like obviously we want to build a home that's as airtight as possible, and with the latest blowing reading this week we're around 0.55 air changes per hour, which is amazing. But once we install these wood heaters and that, you know, they say they're airtight, but how airtight they are once you start talking airtight homes, we don't know. But it doesn't faze us. Like we're not, you know, trying to hit an actual airtight figure. If it's 1 air change an hour when this home's finished, time the wood heater's installed, because we get a little bit of, you know, draft, so to speak, through it. It doesn't matter. It's really important to the owner here. He likes, you know, fire. It's very calming for him in that. So, you know, it's something that we really respect for that. He wants this in the home and that. So, yeah.
Yeah, I mean, that's a great thing what we can achieve here, working in collaboration. And there's a few examples of that in this project where we've had better outcomes just working together.
Yep.
The portal frames were originally trusses, but due to the structural engineering requirements and the wind rating here, we were able to remove a lot of the structural requirements or bracing that would have been in place for those, and instead replace them with these portal frames, which ultimately have become a better outcome, I think, just aesthetically as well. So there's a story there for anyone who's interested in knowing more about that. I won't dive into the details now. Heating and cooling. So with a home such as, you know, a high performance home such as this, or a hybrid home, we still do require heating and cooling, auxiliary heating and cooling, and we traditionally will just install a reverse cycle air conditioning system. That's usually enough to facilitate the heating and cooling requirements. And like we mentioned before, it's quite easy to overheat in an airtight home, so we want to ensure that there is the ability to cool it if necessary as well. Yeah, it's, again, the data we've collected from some of these homes, heating might be, you know, during the peak of winter, you might have it on for 1 hour in the morning and then 1 hour once you return home at night, and that's probably enough to sort of stabilise the home's internal temperature.
Yep. So to get this home airtight, I'll chat more about it when we move down there. It's a bit better to see, but there's a few little things I'd like to point out here is we use plasterboard to get this home airtight and our external building wrap. The reason of that is that it just comes from a cost perspective. A lot of the high performance builders can use a product, ProClime have a product called Intello, and that's just a dedicated airtight membrane. And for us, it's like, well, that's a whole labour component that you're required to do to install that, and that's also a whole, you know, set of materials and tape that you're required to, you know, bring on site. It just adds cost. So for us, plasterboard, you need to use it. You should use plasterboard anyway, or some form of lining. And plasterboard works really well when it's a continuous sheet. It's airtight, but you know, we all know that you're going to have penetrations in your plasterboard. So you can see here we've got a power point in that, and normally with that right now you just see insulation and then this little metal bracket. But we actually, I've got examples out the front there, use these plastic boxes that we polyurethane up. So the plasterboard's polyurethane to that airtight box, then at the back that's all sealed up. And another example of the continuous, or the plasterboard is where we've got these timber portals coming through. Because these are structural, that we need to install them when this at frame stage. I didn't want to put any plaster in the home then, obviously for, you know, the reason. That we put a starter strip of building wrap behind that, and then so that building straps continue, the piece of wrap's continuous either side. Then we polyurethaned the building wrap to our plasterboard. So it's, once again, plasterboard's good if it's continuous, but once you start breaking it, you need to start thinking about how you're going to make it, you know, continuous and that. And it's similar to, which I can show you further down there, but we use 2 bottom plates, but the plasterboard's been polyurethane to that very bottom plate, which is an airtight plate, but we can show that in a bit more detail down there.
Yeah, so the reason for that is that's what we're going to call our airtight plate. So that bottom plate can be polyurethane and is placed down on the concrete slab to create a continuous air seal without that struggle of trying to lift 140mm thick stud walls, which can be quite weighty, and that movement can sometimes break that seal. So it's just a really secure way of being able to provide that air seal. I'll ask everyone before you dive into those details to cast their eyes down the house though, and you'll notice that the plasterboard continues right through, and then the walls just stood up and installed secondary. So only a couple of weeks ago, if you were standing here, you would not see any of those walls, but you would still see the continuous plaster. So we had this one giant capsule.
Actually, if it was Monday last week.
Monday, there you go.
Just gone, it would have been no frames
so,
up.
So the home was able to basically become airtight within 2 to 2.5 days, which is pretty significant given the requirements of having to install wrap as well internally. So yeah, there's a few little nifty devices that allow us to achieve this. Some of those who are familiar with building will be familiar with L brackets or similar proprietary products that you must have connecting those internal walls to the trusses, but we've used a screw in lieu of that, which achieves, probably even better results actually, and allows us to have a continuous airtight plaster layer on the ceiling as well. You'll notice blockwork as well that's sticking down. That's where we're going to run our HRV ductwork, or a continuous mechanical ventilation ductwork. We want to ensure, as it's uninsulated, that it's installed below the airtight layer and the insulation layer to reduce any condensation occurring. So we're going to install a finished plaster ceiling directly onto that blockwork, and then have our ducts for our HRV system running through those. We only need to, with this system, we only need to lower the ceiling at locations where the ducts need to be run, and we'll, for example, on the opposite side we have a bedroom and there'll be a fresh air supply, but that will just be a wall-mounted grill that actually comes through into that surface cavity. So we don't have to go through and lower that ceiling to install any ceiling-mounted ductwork or anything as such. And I encourage anyone, if they're interested to see more of that, to jump onto either our YouTube channels or whatnot and have a look at a previous project that we documented on all of that. So, let's
move forward.
Yeah, I think so.
So R4 external walls, R7 in the ceilings. So for the cathedral ceiling, it's a single layer of R7. For the flat ceiling, the bags are sitting in the ceiling. We're going to come back and it's actually two 3.5 bats run their crosshatch. They run in different directions. They're actually running it through the truss frame to encapsulate the truss frame in insulation. And the R2.5s there for the internal walls.
Yep, so the whole purpose of doing the two different layers of insulation is that we want to minimise any gaps. So by obviously doing the two different layers, crosshatch at 90 degrees, you're going to have joins in different spots. So to minimise, less insulation, that sort of thing.
Yeah.
So,
we're going to also do a blower door test in a moment as well. So I'm going to close these up, but before we turn on the generator and run the blower door, I'll just let everyone know that, if they feel claustrophobic or anything, to just step outside. Hopefully you can still see a view through the window, but just thought I'd let everyone know that.
Cool. So I'll just start chatting about what I call advanced framing techniques. So you'll see a lot of homes in Australia, or especially custom builders, maybe not volume builders, space their studs at 450 mil centres, but here we actually space the studs at 600 mil centres. And the whole purpose of that is that when I was an apprentice, I was always taught to build with more timber. Timber makes things structurally sound, and that is 100% right. We've got structural integrity to keep in mind, but the less timber you put on your external walls, the more insulation you can install. So it's about trying to build smarter, not just throwing studs in willy-nilly and that sort of thing. Studs at 600 mil centres, as has probably already been talked. Normally studs are at 90 mil stud depth. We have 140 mil stud wall, so we get that R4 insulation bat in. And you can see, if anyone's up close, you can see we have the two bottom plates. So the very bottom plate's that air seal plate that Anthony just spoke about. As we were saying, that when we're framing, that you do it over like a 2 or 3 week period, and we were framing this a couple of months ago, and it was on and off showers, wet, and we're trying to glue a bottom plate down to the slab. So if you're doing that over a 3 week period in the middle of winter, there's a fair chance you're going to have a wet day. That glue's not really going to bond well to the slab and the timber, and then you've got air leaks and drafts and that sort of thing. So that's why we come to the idea of the air seal plate, is that we just dedicate a day at the start of framing to go around, we can actually cut the same bottom plates, but cut them twice, and glue down that first plate, so it's 100% sealed. And the other thing is too, that like anyone that's a builder and chippy in here, that to lift a 140 mil stud wall, even just a big 90 mil stud wall, is bloody heavy, and to try and drop that directly onto a piece of polyurethane glue is bloody hard. So another thing is too, like when you're doing the air seal plate, we're just focused on air tightness. That's all the whole purpose of the day is, air tightness. Then when we're framing after that, we're just framing. Another thing is too, like it's only minor details, but I believe all this sort of stuff adds up, is that traditionally you would see an extra little jack stud running down next to that one, or even a block in there, but we don't do that. We actually just drive a batten screw in through there into that, so that the weight of that window, we've got a screw there holding it up. So once again, one less little bit of timber. anywhere we've got our little jack studs up the top there, that's actually been twisted around so it's on its flat. So from there back that timber only goes 35mm deep in, so we get insulation bat in, again, less thermal bridging. It's just about trying to build a bit smarter and actually really think about what we're doing.
Yeah, I mean, you've touched on basically thermal bridging a few times. So this home is essentially thermal bridge free. We have a few steel power truss braces, one here, and there's one actually just on the corner on the face of that vestibule there. And there's XPS, 50mm XPS insulation installed on the outside face of that to its entirety, stopping any heat transfer that occurs through steel, because as we all know, steel's a really high thermal conductor of heat. So, if you put a flame on that, it would transfer quite quickly. And so by putting that XPS insulation there, we've stopped that reduced that heat transfer from occurring. And even to be further along, there's glass wall insulation bats installed in amongst it as well.
Just talk about California.
Sorry, secondary to that, also having thermal bridges, the other factor of that is that if you have cold surfaces inside a warm room, then you've got potential to reach dew point.
So I'm going to stick right in the corner.
Water that's a gas in the air will turn back into liquid, you end up with condensation. So by having the insulation separating that steel from the outside, then that way that steel's kept warm and is kept above dew point.
Yeah, very good.
Eliminates condensation.
So for you guys that can see, this is actually a bad example, but it's the only example we've got here. But so normally on a house like this, you'd have a 3-stud corner. So there's a stud here to pick up plaster internally, and then normally there's a stud going back that way all the way to the outside, that's picking up plaster too. And then normally there's a stud on that back edge there for the cladding. But again, we're trying to build smarter. So the traditional corner is called a 3-stud corner, but this is called a Californian corner. We've got a stud there, you can see. There's a stud going back that way at the end there for cladding. And then you see where this plasterboard's fixed in. That's actually a piece of 17mm plywood that's been fixed in, you actually see the nails there, through the back there and that. So again, we can get an insulation bat pocketed right through the back corner there. So again, one less piece of timber, so one less thermal bridge, but your insulation's getting continuous, because what normally happens with a 3-stud corner is that your frame, the house gets wrapped, and then the wrap gets put on the outside, and then you get a pocket there that gets no insulation whatsoever in it. And again, that makes a cold spot in winter and a hot spot in summer and that. So it's about to get building smarter. So yeah.
So right now, if you can sort of envision, we've got that insulation under the slab, and that continues up directly to the underside of that top plate there. And then that insulation in the walls continues up into the ceiling. So we've got this perfect continuous line of insulation. And we're doing that with the air tightness as well. So we've got that plaster airtight layer here, and that continues down the walls, and then it joins the slab. So we've now got that perfect continuous airtight layer under the insulation, or inside of the insulation layer. So it's, yeah.
Yeah, you'll see the 2 wet areas. So as far as the bathroom and ensuite down the far end, we actually recessed the slab 35mm. That way, that this is going to be a burnished concrete slab in here, that when we tile that bathroom in there, that you just get a smooth transition across, no tripping hazards. A lot of guys, which is fine, do just pull those areas the same height, and then you just have a little lip about 13mm higher and that thing. But on this project, we're avoiding that. So
yeah. Can you remember the NatHERS rating on it?
No, 7 something, 7.8 or something like that. Yeah, I'll find it.
Yeah, I can't recall.
So the HRV, as Anthony was saying, that this home being airtight, we're required to ventilate it. HRV ducting or HRV unit is installed just past those ladders in the laundry. That's just in a cupboard. It's a Zender product. I think it's a 300?
350.
350.
Yep.
So the whole purpose of that is to ventilate the home. It extracts air from your wet area, so extracts air from your bathroom, ensuite, laundry, kitchen, butler's pantry in this case.
Yep.
It then goes through back to the unit itself in the laundry, goes through the core, which is a baffle sort of system, and it gets extracted outside. But when it's actually, when it blows the fresh air in from the outside, it blows air to the bedrooms, the living areas, but it actually recovers 90% of the air temperature that it extracts out. So it's not blowing in the middle of winter, it's not blowing cold air into the home. When the air gets extracted through the unit, it recovers 92 or 93% of it, I think.
Yeah.
And yeah, again, it's...
Yeah, so again, the reason for that is to reduce the requirements around auxiliary heating and cooling. So it's, improving the energy efficiency of the home. Mostly for me though, it's probably the indoor air quality that I like the most for a ventilation system such as that. So one, it is going to control we'll control the indoor relative humidity. So we know that mould develops sort of 60% or on. So far, all the data we've retrieved from our projects has indicated that it sits somewhere around 40 to 50% consistently all year in the indoor relative humidity. So we know that that's sort of mitigating that any mould growth or risk. As Stuart touched on before too, when you've got surface temperature differentiations as well, that can increase the likelihood of mould growing. Now, I don't know if anyone here has woken up in the morning and they've seen condensation pouring on the inside of their window frames, but that's what that will also assist in preventing. So we've got airflow movement ever so gradually throughout the home, and it's basically reducing the likelihood of that temperature, surface temperature, being different in the home as well. So.
Yeah. And it's great for, it's great for extracting VOCs. Obviously, when this home's freshly painted and that, and we've got new cabinetry that is going to ventilate all those VOCs out of the home, so it's continuously blowing fresh air in. And on this project, we actually have a bypass system. So the HEPA filter, which is the bypass system, is designed to, when smoke's in the air. It's designed that it's a manual system that you put the filter in, and the HEPA filter removes all the odour of the smoke smell, where traditional the F7 filters don't. They just remove the pollens and that out. So
yeah. On that note, I think we might just run the blower door and allow everyone to then get some breathing space. I think so. Anyone who's not that keen on having any issues with depressurisation, or if you're in the aeroplane and you get any issues with that kind of thing, it's going to be very similar to that. So we're, we get an opportunity to jump out.
30km/h winds.
Yeah.
On all four sides of the house.
All right. I'm going to give everyone the quick rundown of this. So basically, the blower door is testing how many in this case, what we're testing for is a quantification. So we're looking to basically see how many times the indoor air volume of this home is going to exchange in 1 hour at 50 pascals of pressure, which is about the equivalent of about a 32km/h wind. So yeah, look, it's not the natural air change. We are intensifying that, but the reason we do that is that's an international testing standard, so we can go anywhere in the world and know that we're going to work with it. I've already preset it. We have to do a baseline first, which basically allows us to test the pressure differentiation occurring from outside to inside, and it makes that allowance in the test itself. We work out the volume. We do that personally in our software that we have, and we then put that into the controller, and it can now tell us how that's going to, how many times that's going to change. So I'll get straight into it. We're going to go set it to 50 pascals. As the home's fairly airtight, we don't need a great deal of aperture. So the fan's just gone a bit too high there. It's just going to correct itself and bring it back down and try and level itself out at 50 pascals.
Has your project come on, Brian? Yes. Yeah? Yeah, good. Yep, great.
So normally what we're doing here during a build is looking for air leakage. And we can do that in a number of different ways. We've kind of done enough tests now where we know where all the leaks are going to occur. So if you were to be standing at one of the lift and slide doors, you'd probably feel a small amount of air leakage coming in from up the top or the bottom. Great thing about it when you do it with your external wrap on is you can go and tape those holes up and seal it up and make sure it's working. And you can also check your plaster board as well in this case and see if there's any air leakage occurring. And if anyone's near one, put your hand near it, and if you're lucky enough, you might feel a little bit of that occurring. It's quite intense compared to like what it would be naturally. So we've sort of leveled out now at 50 pascals, and we're getting a reading of 0.56 air changes an hour. Now that would meet the requirements for the Passive House standard. It has a requirement of 0.6 air changes an hour, so that's a really great result for us because we don't have a dedicated internal membrane. We're just relying here on the external wrap and the plasterboard to be our airtight layer. And you know, these are standard materials that are going to be used in any build anyway. So just through a little bit of detailing and thoughtful consideration about the methodology, you can definitely get these homes just using plasterboard down to, you know, that 0.6 requirement for Passive House standard.
Yeah, it's amazing.
All right.